Hey everybody, let's look at the extremes and intervals, kind of finishing up our unit on graphing polynomials. And then the last question we'll kind of run through just about everything, kind of as a quick review. So, minimum and maximums, these are also known as extrema. You see that kind of a new term. You'll need to label each point as a relative or local min or max or absolute min or max. So we can find these algebraically or graphically. So here are the steps for graphically. This is for your basic TI calculator, so a TI 83 or TI 84 or whatever you have that's comfortable. If you don't have that, you can use Desmos. That is what I use on my iPad. You can type it in there and you can click on the points that you want to find. So however you want, you can graph it. You can find maxes and mins that way. So your terminologies here, relative or local max or min, we'll use both of those terms. Most of the time I'm going to use local, but I will use relative here or there. Those are the extrema in one specific part of the graph, so one little area. Absolute max or min, I'm never really going to use global. This is the extrema over the entire domain. So what's the biggest point on the graph, or what is the lowest point on the graph? The biggest thing with these is that they only use y values. I don't care about the x, I'm just looking at the y values. So whenever you're looking for a minimum, you're looking for that U shape. Whenever you're looking for a maximum, you're looking for the top of a hill. So if we take a look here at number 1, what I want to find here is I want to find, let me zoom out a little bit more. Let's start with our locals. So our local max, our local min, our absolute max, and our absolute min. So those are 4 things I want to find here. So let's take a look at here. Here I got a top, I got a mountaintop. So here we'll round this point. Each one's going by 2, so we'll call that -2 and 2, 4, 6. We'll call this point right here, we'll call this just 0, 3, just to make things easier. So a local max, I'm looking for anything that's got a mountaintop. So here I have that at y equals 6. A local min, I'm looking for anything that's a U-shaped graph, so I have that right here, and that's y equals 3. Now, absolute max is the highest point in the graph. So I see this goes up and down or up forever. So it's never going to touch anything. So I cannot have, wow, I tried to write not, then I tried to correct it and go to none. So I do not have an absolute max here. Same concept. If I'm looking down here, it's going to go all the way down to infinity. Since I don't know what infinity is, I do not have an absolute min. So you're looking for the bottoms or the tops there for absolutes. All right. Over here, let's take a look at this. So once again, I got my local max. I got a local min. I got an absolute max and an absolute min. So these are the things I'm looking for here. So remember, local max, I'm looking for a mountaintop. I don't have one. This point right here, 1 over 1 up 2. I do have a U shape here. So I do have a local min here at y equals 2. Since there is no local max, there's not going to be a local min, or an absolute max, sorry. My absolute min, see how this is the very, very bottom part of the graph? So it's a local and an absolute max, or a minimum, because it's the very, very bottom of my graph. Nothing goes below that specific point. Okay? And the last one, we got this. So we got local max, we got local min, we got absolute max, and absolute min. All right. So once again, at local max, we're looking for, oops, that's backwards. We're looking for a mountaintop. So any mountaintops I see here. This point right here, we'll call this, we're going by 1, so negative 1.5. 1, 2, 3, 4. Whoops. I'm not looking at y-intercepts here. We'll call this point right here, we'll go 0.5, 1.5. Call this point 1, 1. So I have a max here. So I have a local max here at y equals 1.5. Local mins, I'm looking for U-shaped graphs. So I have a U here. So that's y equals -4. I also have a U here at y equals 1. So I got two pieces there. Absolute max, it's going up forever. I see that here, and I also see it here. So there is no absolute max. Now, absolute min, here's the lowest point of my graph. So I have an absolute minimum here at y equals -4. So it's both a local and an absolute. Cool? All right, so there's my max and my mins. Let's come over here. Let's look at intervals of increase and decrease. Using the same graphs as before. We're only going to use the x values here, where it's increasing. So colors are definitely useful here. I'm going to use blue for increasing and red for decreasing. And we're only going to use our x values here. So we'll do the same points. So this one I said was what? -2, 6. This point right here I said was 0, 3. So my x values here, -2 and 0. So if I'm looking at this part is increasing because I'm going left to right. This is going uphill. And then it's going to go increasing over on this part too. This part's decreasing. So if I kind of draw it down here on my x-axis, this kind of helps me represent it. And then left is always -infinity, right is always +infinity. That way when I'm writing my intervals at the end, it's just easier for me to look for. So I got increasing and I got decreasing. So my intervals of increase here, if I go left to right, it's starting at -infinity. It goes all the way up to -2. At -2, it changes. So from -2 to 0, it's decreasing. It's going downhill. And then we pick it back up at 0, and it's going to turn, and it's going to go up forever. So my intervals of increase and decrease. That's why I draw it at the bottom too. In purple, I labeled my x points. I got -infinity and +infinity, and then my x turning points, so at -2 and at 0. So that way I can color it in here. It's just easier for me to look at it that way. All right, let's look over here at number 2. Here's my minimum here. We said this was 1, 2. So here, it's the only turning point for my x. So I got -infinity and I got +infinity. So I got increase and I got decrease. So it's starting off, it's decreasing. The whole graph's decreasing. So from here till 2, it's decreasing. At 2, it turns. We got a minimum, so it turns and goes to increasing. So we're going to start off decreasing. So from -infinity to 2, it's decreasing, and then it changes from 2 to infinity. It starts increasing. Once again, we're using our open parentheses because at -infinity, you don't know what you're doing. And then at 2, it's actually turning, so it's not changing, or it's not increasing or decreasing. It's actually got a slope of 0. All right, lastly, we said this one was -1.5 and -4. We said this was 0.5, 1.5. This was 1, 1. So my x values here are -1.5. I got 0.5 and I got 1. +infinity and -infinity. So I'm finding increasing and I'm finding decreasing. Whatever. So I'm going to start off, we're starting off decreasing left to right. So we go decreasing, then we switch, we go increasing, then we switch, we go decreasing again, and then we switch and we go back to increasing. It always alternates. So I'm increasing from here to here and here to here, and I'm decreasing from here to here and here to here. So -infinity to -1.5, and then 0.5 to 1. And my increasing lines are -1.5 to 0.5, and then from 1 to +infinity. And colors do help. Drawing the line at the bottom does help as well. So on and so forth. So we got our max and mins are decreasing and increasing. And then here, I'm going to kind of summarize a lot of what we've done. So first, I'm going to take this equation. I've already graphed it on Desmos, so that's what this is over here. This is going to be your max and min, and I'll show you that in a second, just to save time. So here, I'm going to get my zeros first. So find the zeros of the equation. So 4 terms, I'm going to group it. Remember that negative here is squarely with our grouping. So I can take out an x squared. That leaves me with an x minus 2. Now I can take out a negative 9. Remember, since that's there, I always change my sign. So grouping is going to be nice. I got an x minus 2 and an x squared minus 9. Remember, right here, this piece, that's your difference of squares. So that factors into x plus 3 times x minus 3. And then bring down your x minus 2. And you have it in factored form. So that means my zeros here are x equals 2, x equals negative 3, and x equals positive 3. So if I come over to my graph, I got x equals 2, I got x equals negative 3, and I got x equals positive 3. So now, let's get kind of a sketch. So my end behavior here, my degree is 3, my leading coefficient is 1. So once again, that's odd and positive, so down and then up. So I know over here it's going to go down, here it's going to go up. So I know it's going to go through this. It's going to come up here, turn somewhere. It's going to come through this and turn. That's these points I plotted over here. So these aren't going to be super accurate on my graph. But so it's negative 1.2 and 24.2 is where it turns up there. Down here it turns at 2.5 and negative 1.4. So that gives me a good accurate-ish graph. With this, if you're labeling it, that helps out. So that way we know what's going on. Now, my increasing and decreasing. So I'm going to do increasing in green, decreasing in orange. My purples here, I got negative 1.2 and 2.5, and I got positive infinity and negative infinity. So we're starting off, we're increasing, and then we're increasing over here. I did orange, and we decrease here. So my intervals of increase here are going from negative infinity to negative 1.2. Then it's picking back up at 2.5 and goes on forever. My decreasing is going from the negative 1.2 to the 2.5. I didn't write the zeros in the blank, but it's okay. I can also go ahead and tell you at 24.2, that's a local maximum. And at negative 1.4, it's a local minimum. We can also write our end behavior perfectly too. So remember, as x approaches negative infinity, f of x approaches blank, and that left side is negative infinity. And then as x approaches positive infinity, f of x approaches the right side, so that's positive infinity. Once again, that's our end behavior, how we would write that. This right here is a local max, a local min, and we don't have any absolutes. Cool. So good luck on your test. I know this video is a little late getting out, but it's okay. I hope everything is going well. If you got any questions, let me know, and I will talk to you later.